quick show of hand of how many people know about 3D printing. Wow, that's really impressive. Maybe some of you should be giving the presentation instead of me. So today I'll be talking a little bit about 3D printing, and unfortunately we don't have a lot of time and to go into 3D modeling, and so we're not going to cover that, but just the basics of 3D printing, and I'm sure all of you already know, but maybe there are a couple of things that you might learn from this presentation. So we'll talk a little bit about the history, what can you do with 3D printing, what the heck is 3D printing, and then just understanding the workflow, such as using CAD programs, using slicer programs, and then some basic troubleshooting. Okay, so when 3D printing was developed in 1984, it really changed manufacturing, because now you have what's called additive manufacturing, right? And so what 3D printing does is you have a 3D model, it works with a computer, and then you start building your model layer by layer. So 3D printing allows people to build components or products layer by layer, which means that virtually there's no waste in the designing process. It also allows engineers to tweak your designs immediately and to prototype extremely quickly. And this is why we call it rapid prototyping. And this is in contrast to subtractive manufacturing, which is what it used to always be, where you would have materials and then you would slowly chip away at the materials in order to get your prototype, right? So 3D printing has reduced the cost of materials, time, and allows for really rapid changes in your design. Components now take a day or two to make instead of weeks or months. And also, 3D printing has become ubiquitous in our society. So since it was created in 1999, you have first lab-grown organs. You also have 3D printed working organs a couple years after that, and then in 2005, open source collaboration on 3D printing really opened up, and then you started seeing a lot more things like DIY makerspaces, service places where people can do 3D printing, and also 3D printing is now available to people like us, right? So now, equipment that used to be so expensive, we all can have in our home if we wanted to. And we can also allow us to make custom parts. So some cool things. In 2012, 3D printed prosthetic jaws was implemented in a guy in Netherlands. And then in 2015, you have the first 3D printed car, which is really awesome because it only takes 40 hours to make instead of multiple weeks. And it's really cheap for $5K instead of several $10,000, $20,000. 2011, you have the first 3D printed robotics aircraft. I mean, how cool is that? That someone can make this and get on it and fly around. And then obviously, a couple months ago, someone 3D printed a house. This is a 650 square foot house. It only took 24 hours to make. And things like this also cost something like $10K to print. Can you imagine what this can do to our society or for our society, especially if it comes to homelessness? So I'm sure you guys kind of know why 3D printing is important, and I just want to, so we're talking about what's happening in the world, but I want to draw it closer to home and what we've been doing here at CoMotion Makerspace. So at the CoMotion Makerspace, we have students from all different departments using our space, and some of the things they've been doing are for fun stuff, right? So you can do things like 3D chess pieces, you can make toys, fidgets used to be really popular, you can design your own fidgets, you don't have to buy anymore, right? Some of the things that my students are also doing are making improvements in our space. So if you take a look at this is a Vive stand, and It's used to hold the Vive controllers. This really helps keep our space nice and tidy, and also when you put your stand in it, it automatically charges. So students are also working on solving real-life problems in our makerspace. So for example, there was a student last week working on Husky Adapt RS, which is a student organization on campus. And what he's doing is he's prototyping a prosthesis arm for a client. I caught him and he was working on the third prototype. But something like this can help someone with with some sort of arm disability. And then some other students are also working on taking a look at the current market for zippers and what they can do to make it more friendly for disabled people with really fine motor skills. So as you can see, 3D printing can have a huge implication on our lives. So how many of you know what exactly is 3D printing? You want to say what it is?
Me? It's where you're printing with matter, plastic or metal or
exactly.
organic matter.
Exactly. So again, 3D printing, you make 3D structures by, in this case, the printers that we have it melts the plastic, and they will add layers by layer to make a 3D model. Also, in some of the things that I'm not going to go into any details with, but there are other printers such as SLA, resin-based printers. Do any of you guys have that at your space? Okay.
We don't have our space here.
What about a powder-based printer? Do you guys have any of those?
We have an Ultimaker too.
Okay, so we have the same thing, and really, depending on what you're using it for, Ultimaker is enough, or the finders really work well for us. So some of the things you need for 3D printers are obviously the hardware, right? You can't print without an actual 3D printer. Again, the printers we have in our space and the one that I'm bringing, the one that we have back there are the Flash Forge printers. We've had them about a year now in our space, and we find that they are very easy to use, very cheap. Maintenance is really pretty easy. It's not as hard as some of the older MakerBots. And then, so Ultimakers, MakerBots. We also have ABS printer, resin. And then obviously, before you can start 3D printing, you need to be able to develop or design your 3D models in a CAD program. And unfortunately, for 3D printing, modeling is a necessary skill that you need to do, especially if you want to customize your own objects. And there are a lot of different options in terms of what kind of softwares you want to use. And some of these designs have really simple capabilities, and then they can range to really complex mechanical parts. And the price could be free. These licenses are free, or they could be as expensive as a really nice sports car. In our space, we have Fusion 360 and then Rhino licenses. They tend to be quite cheap, but SolidWorks is a little bit more expensive for our space, and because most of our students are not just mechanical engineers. And also, SolidWorks is not as intuitive as Fusion 360, and so those are the things that we have in our space. So can someone tell me what happens after you get a CAD file?
You have to slice it.
Okay. And before you slice it, what kind of files can you, what kind of?
File?
Yep.
STL or OBJ.
Okay, yeah. So an STL file is a stereolithography file, and what it does is describes the surface of the surface geometry of the 3D object, and does not take into consideration the texture or the color or any other CAD attributes. And the reason, and so what it does is it turns these objects into triangles, and triangles are defined as coordinates. And this is helpful because that means that you can take an STL file and design it in Fusion, and it could be read in a program like Rhino or SolidWorks or AutoCAD or Tinkercad. So what we mostly work in in our space is STL files. But what if you don't know how to do 3D modeling? There are a lot of different options for us out here. Things like Thingiverse, UImagine, Trace Parts, GrabCAD are some of the resources that you can use if you don't know how to model yet. And for most people, I would say that that's probably the best way to go into, because some of the other details can be a little bit overwhelming. So once you have your STL files, you have to slice it in a program, because what a slicer does is that it takes a 3D model and it transforms into something that the 3D printer can read. And in this slicers, you have a lot of different settings that you can adjust. Things like revs, heights, supports, InFields that you can change depending on what you're making. Okay, so when you are putting settings onto your 3D models, there are a lot of different things that you have to think about, and it's not really obvious until you've tried 3D printing a couple times. And one of the first things I always think about is part orientation, right? How does your model lay out on the slicer program? We find that wide flat prints are much better. They come out much better, and they're less likely to fail than really tall parts. So the other thing to consider is that less support material means that you're not wasting as much filament. And then obviously, with the, depending on what you're putting on, support structures does not always come out cleanly, depending on what your design is. And so there are pros and cons with parts, orientation, and then support materials. So if you take a look here, which of these files do you think comes out best?
The upside down with the support material.
Why is that?
Because it has more surface contact.
Exactly. So that's a consideration of your 3D printing. And a lot of it is based on experience. If you're printing for a first time, second time, if you're really smart, it might be really intuitive. But for me, it took me quite a while to figure out that laying it down flat where most surface touches the level bed is the best print. Okay, can someone tell me about what's going on here? Go ahead.
Support material is used, and it looks like polyvinyl acid.
And what if you don't have a support material?
If you don't have support material, then it'll probably fail.
Correct. So here's also another example of support materials or overhangs. Support is generally needed whenever you have anything that's at least 45 degrees horizontal from and of any significant size. And then if you take a look at the left,
Can you explain that? I think a lot of people here don't understand what happens when you get a fail. I mean, can you talk about what happens with the spaghetti?
the spaghetti.
Well, the printer is printing from the ground up.
Yep.
So it has to add to each piece is going up.
Yes.
And I don't think people understand that you're talking to this audience. It's a vertical print, so it starts from the bottom and it goes up. And if it can't branch out, left to right, then it fails.
Oh, I mean, 3D printing can't print on thin air, right? And so it's kind of like, if you have a chair without legs, is that going to be a chair? Is it going to stand, right? Or if you just have something like this printing, imagine I'm printing this on a level bed. There's no contact. It's obviously not going to print, right? Where are all the layers going to stick together? If you have something that is slightly angled, and pretend this is the level bed, you're going to start printing here, and then it's going to slowly, the layers are slowly going to attach, and you can build all the way to up here, right? But if you have an angle something like this, do you think this is going to work? Why is that? Your angles are over 45 degrees. There's no support. And it's just the layers are not going to stick together. So you need supports, and supports are built down the level bed, and it's kind of like a tree where they can branch out like this and hold your pieces together. It might be better if I give you a walkthrough later on that, and we can print out things that have no support and then things that have support so that you can visualize it. Then another really big consideration is rafts. Rafts are needed for the 3D model to adhere to a printer bed. Some designs will generally adhere better with raft. It will come out much better with raft. So generally, raft is used to is to make a connection between the 3D printed piece and the level bed. In general, I would say that if a model has a really large surface, then a raft is not necessary. But if you're working with something that's really fine and very detailed, then you probably do need a raft. And if you're ever in doubt about whether or not you need to use a raft, you always err on just put a raft on. Material is cheap, let's put a raft on, and then see what happens. Sorry, so that's the raft. InFields. So InFields provide structural stability and support for your print. And this is the thing that goes inside the model. And so generally when you 3D print, you always ask, what's the purpose of the print? If it's an ornamental print and I'm just gonna look at it, it's gonna be nice, I don't really even bother putting infills on it, or I put a 5% infill. If it's going to be used for some sort of structural thing where it's going to get abused or you're traveling with it, then generally more infill is better because it's sturdier. But the thing to know is that the more infill you put in it, the longer it takes to 3D print. So really up to you about how you want to approach it. In general, we find that a 10% infill works for most people's parts. Okay. Does anyone want to go and talk through some of the troubleshooting with me? There are some experts out here. Yeah?
So, what do you mean by common troubleshooting?
What are some of the common issues that you run with 3D printing, and how do you fix it?
My most common issue is things unadhere from the build plate mid-print.
Yep.
65-hour print.
Okay. Anyone else? Can you said that one of the biggest problems is 3D models not adhering to the bed plate. Do you know why, or some of the reasons why?
I think that in my case, it's because I don't use a heated bed
Okay.
printer.
Yep.
And I don't use like hairspray or glue or anything needed to stick.
Yeah. So sometimes the bed level is not high enough, so the model is not going to stick. Or sometimes the bed level is going to be too hot, and then the model can't really stick well, or it's not going to cool enough so that it sticks. It's just going to be good. Some solutions that people have used are using hairspray, glues. They tend to be quite messy. One thing that we found and is useful is high temperature tape. I mean, that's not cheap, but it works all the time. That's also what we have in the back. Has anyone had any problems with the infields? Really high infields?
I've had a problem with infills before.
Yeah.
Like when I'm printing a model that has a large flat surface, if the infill's low enough, then the top layer will cave in.
Oh, right.
Yeah.
So the only fix for that is making the infills what? Higher? And then, okay, good. So sometimes when you're 3D printing, it's also important to think about how fast you're printing, right? The faster we print, what does that mean?
Lower quality generally.
Lower quality. But the slower we print, what does that mean?
Higher quality.
But it also takes forever,
Yeah.
right? So there are pros and cons you have to think about. So I just listed a couple couple of troubleshooting things that we commonly come across. Cleaning the build plate often helps. Sometimes if you're not careful, the filament spool will tangle up in the bag, and then tomorrow morning you come in like, what happened to my print? How many of you actually do maintenance of your own machines? What are some of the most common problems you encounter with maintenance?
Extruders clogging.
That's a pain.
Yeah.
It sometimes takes several hours to unclog an extruder head, if you can remove the extruder head, right?
I couldn't do that.
Really?
Yeah, I messed up so bad that I had to replace the entire thing.
The entire thing?
The entire extruder assembly.
Well, we can talk later. I can give you some tips if you want. Because we work in a makerspace with over several thousand students, and a lot of the times our machines are running 24/7. And then we also have people who don't quite know what they're doing, and so they remove prints and then break the pieces in there. And it's like, please ask me. So common troubleshooting issues are listed above. If you encounter any of them, you can just go through one by one and see what works for your model. Unfortunately, 3D modeling has a lot of different failure modes, and it's not really clear and obvious at first what's the issue. So you do have to troubleshoot a lot. Okay, so as you all know, 3D printing fails all the time. Right? The printers are really complex, and the machines are, there's a lot of different failure modes. Printing just doesn't happen overnight. Oftentimes it takes, I think in general, my students take about maybe about 10 weeks to 3D print, and then get really, really good. Because once you start 3D print, you become really familiar with what works, what doesn't work. And then if you're doing a lot of advanced settings, you get to play with the settings. And then you'll know that if your model has overhangs or different angles, then the best setting is something. In space if you want. You can move it out, it's not going to print, but you can move it back in.